Let's see what question number 8 says. The curve C with equation y is equals to f of x is shown in figure 4. Alright, the curve C has a single turning point, a maximum at 4, 9, so here it is, crosses the coordinate axes at only two places, that is minus 3, 0 and 0, 6, has a single asymptote with equation y equals to 4 as shown in figure 4. State the equation of the asymptote to the curve y is equals to f of minus x. Okay, f of minus x basically means that we are going to reflect this curve along the y-axis. Now, if I reflect it along the y-axis, that means the horizontal asymptote will not change. So basically, this will be reflected from here to here. Okay, and that's it. The equation remains the same. Okay, so the answer to part A, how many marks is it? It's a 1 mark question. Yep, it's just a tricky one. And that is y is equals to 4 only. Okay, so because it is, this is for what I'm writing in the brackets is for your understanding only. So because it's reflected in the y-axis, therefore remains unchanged. Okay, so the equation of the horizontal asymptote remains unchanged because you're just reflecting it along the y-axis. So think of it this way. This is the mirror, okay? Here is a line, and what happens if you reflect this line along this mirror? It's drawn over here. So the equation remains the same. They're both horizontal, so therefore, and they haven't moved vertically, so therefore the equation remains the same. Okay, so I hope that's clear. Now let's have a look at part B. Part B says, state the coordinates of the turning point with equation y is equals to f of 1 upon 4x. Okay, now, first of all, let's understand what is f of 1 upon 4x to begin with, as in what transformation is this? So this is basically a horizontal stretch, okay? So this is a horizontal, stretch, horizontal stretch, okay? That's not enough. We also need to write down the scale factor, and the scale factor or the stretch factor, which is equal to 4. Now, how do we apply this to any point? So if you have x comma y, and if you are supposed to stretch it horizontally with a factor of 4, so the point gets divided by the coefficient of x. So if the coefficient of x is 1 upon 4, the point will be divided by 1 upon 4, okay, and y remains unchanged. So that means technically the point gets multiplied by the stretch factor. Okay, so what's the stretch factor? The stretch factor is what will the new point look like? That will look like 4x comma y. Now, what are we supposed to do with this? We're basically supposed to apply this on the turning point, if I'm not wrong. State the coordinates of the turning point. Yep, that's correct. So previously the coordinates of the turning point are 4, 9. Now, if I stretch it horizontally with a factor of 4, that means now the x coordinate will be 4 times 4 and the y coordinate remains the same. So that means the new coordinates will be 16, 9. And there you go. That is your answer. Okay, now let's have a look at part C. Part C says, given that the line with equation y is equals to k, where k is a constant, intersects at exactly one point, state the possible values of k. So that means we're most likely looking for a range of values. So y is equals to k is a horizontal line, and we have to make sure that it intersects the curve at only one point. So we have to make sure that the horizontal line intersects the curve at only one point. Now here you can see that this is the asymptote. Okay, now the asymptote, this line is not going to intersect. Okay, although it may seem like it's intersecting, but it's not. It's an asymptote. Okay, it's going to get closer and closer to this part of the curve, but it's never going to intersect it. Okay, so that means at y equals to 4, if you draw a line, it's going to be it's just going to give us 1 point of intersection. However, if you draw a line at any point greater than 4, you will have 2 points of intersection, and at this point you will just have 1 point of intersection. Okay, and above this you will have multiple points of intersection. Okay, so that means one possible value where you can have 1 point of intersection, okay, that's what it says, right? Yeah, intersects at exactly 1 point, is if y is equals to 9. Okay, if you want to make sure that the line and the curve intersect only once, so y is equals to 9, and if y is equals to 9, since we're supposed to write down the value of k, that means k is equals to 9. And the other way that we can make sure that the line and the curve intersect only once is to make sure that the line that we draw is below y equals to 4. So that means for as long as y is lesser than or equal to 4, the line and the curve will intersect only once. So that means the other possibility is lesser than or equal to 4. Therefore, the other range of k is lesser than or equal to 4. And there you go. This is the final answer. Okay. Now, part D. And I think D has two parts. Yep, part 1 and part 2. Given that the new curve has equation, oh, no, wait a minute. The curve C is transformed to a new curve that passes through the origin. Okay, now the curve is passing through the origin. Given that the new curve has equation y equals to f of x minus a, state the value of the constant a. Okay, so if I want to make sure that this curve passes through the origin, there are two ways that I can do it. One is that, like the question says, I can bring it 6 units down. If I bring it 6 units down, so that means it will pass through the origin. Okay, so one way to do it is to bring it 6 units down. Okay, and who's going to do that? Basically, A is going to do that. So that means, how do I bring it 6 units down? If I want to bring it 6 units down, it would go from y is equals to f of x to y is equals to f of x minus 6. Okay, so that means the value of A is equal to 6, not minus 6. The value of A is equals to 6 because there is a minus already in the equation. Now let's have a look at part 2. Part 2 says, write down an equation for another single transformation of C that also passes through the origin. Okay, so one way to make sure that it passes through the origin is by translating it vertically. Another way to also make sure that it passes through the origin is by translating it horizontally. So what if I move it 3 units towards the right? Now, how do you make a curve move 3 units towards the right? You subtract 3 from x. Okay, so the other way to make sure that the curve passes through the origin is to move it 3 units right. Okay, and how do you move it 3 units right? Here's how you do it. So if y is equals to f of x, you can turn it to y is equals to f of x minus 3. And now the curve will definitely pass through the origin. And this, fellas, is your final answer. Let me have a look at what exactly was the question. Yeah, the question was asking for an equation for, yeah, so here is the equation of the single transformation.